In homework 5.4, we're dealing with parabolic motion. These are things that move in a parabola shape, and mostly that's going to be when you throw something into the air, it comes down, or anything goes into the air, it comes back down. That makes a parabola. Everywhere on Earth and elsewhere. So this first one is Daisy is mad at her phone, so she drops it out of a window of her friend's third-floor apartment. The quadratic equation that models the height of the phone during its flight is h of t equals negative 16 t squared plus 64. So we want to be able to graph this. And we know a couple of things. We know that this plus 64 tells us the y-intercept. This is in standard form. So I'm going to go up by tens here. 10, 20, 30, 40, 50, 60, 70. So 64 would be right around here, just a little bit below, between 60 and 70. I'm going to go ahead and factor this. I'm going to put this in factored form. It's going to be, I can factor out a common factor. This is negative 16 times t squared. When you factor out the negative 16, this becomes minus 4. Negative 16 times t squared is negative 16 t squared. Negative 16 times negative 4 is positive 64. This is a quadratic that can be factored more. I'm going to leave the negative 16 alone. And I can factor t squared minus 4 into t plus 2 times t minus 2. So this is in factored form, and it tells us what our x-intercepts are going to be. We're going to have an x-intercept at t equals negative 2 and t equals 2. So at t equals 2, I'm going to just count 1, 2. This is where her phone hits the ground. Now, at t equals 2, this is where her phone hits the ground. I should label my axes. This is time, and it's being measured in seconds. This is height, and it's being measured in feet. If you can't tell from the thing, it doesn't actually say anywhere that it's feet in seconds, but you can tell because of this negative 16 t squared. If you're on Earth, this is the effect of gravity if you're in feet and seconds. So because of this, I knew we were in feet in seconds here. So the question is, what does the rest of this parabola look like? Is this the vertex? Is the vertex somewhere else? To find the vertex, you need to take the average of the two x-intercepts. So negative 2 plus 2 divided by 2. That's 0 divided by 2, which is 0. The vertex occurs when t equals 0. That's when the vertex happens. So this was the vertex. And if we didn't know what the vertex was, we could always just plug in t equals 0 and get negative 16 times 0 plus 64. That's 64. That is the vertex. This is what the parabola is going to look like. It goes down by 16 compared to the parent function. And so it looks like this. We don't graph the negative side because this function has a domain restriction where really she didn't start throwing it until it's not like the phone flew up into her hand. It started when she dropped it. So this is where it begins. The starting height of the phone, we can see that right here. I'm going to let you fill in the rest on your own. Think about the vocabulary words you would use. The maximum height of the phone is the vertex, and in this case that is also right here, although usually it isn't. How long is the phone in the air? Well, the phone started going in the air right here, and it hit the ground right here. So how much time passed? Well, the domain and the range. I will help you out with this one. The domain is all the possible x values for this situation. So the domain is all the values of t between 0 and 2, including 0 and 2. Or we could say the times between 0 and 2, like this. This is saying that this parabola only really existed between time equals 0 and time equals 2 seconds, because after 2 seconds, it hits the ground and maybe it bounces, but it certainly doesn't keep going into the ground. And before time equals 0, she hadn't thrown it yet. The range, this is the domain, the range is the height values. And the height values, the lowest height is when it hits the ground. The lowest height is 0, the highest height is 64. So everything between 0 and 64. So, or we could say 0 less than or equal to the height, less than or equal to 64. Hopefully that's helpful, and you do well on the other problems.